Hello everyone. In this video I want to show you one of the amazing tools that is available in MATLAB, especially if you're working with data, and that is this one here called clean data. So to demonstrate that to you, here I have a sine function which has, let's say that's the signal I get from somewhere and from any sensor, and I added a bunch of noise to it. And then I added some outliers and I removed two of the data by converting them into nan. And then this clean data tool, the type of data it accepts is not a regular array. It has to be table or time table, okay? So it does not accept regular arrays or matrices. So what I did was, I used the time table, which is one of the specific types of variables that it accepts. And there is this command in MATLAB that converts your arrays into a time table. So I use the command array to time table and then pass to it the x data, or the transpose of that, which is a column vector. And then each row of this column vector needs a time point, a timestamp. And that is added by this tvec, which specifies the row times. And this tvec, you see the way I did it is using the command seconds. So I said the seconds goes from 0 to 3.1, which is around pi, and with increment of 0.1. Okay, so I create timestamps with the command seconds. I pass that and my original data to this, and now tt is going to be a what? It is going to be a timetable. Let me run it for you. So if you look, you see tt is 32 by 1 timetable. You have time, you have the z values, and these are the time points. These are the x or z values in this case, and this kind of data is what you can import into this amazing tool. So let's go ahead and see what it does for us. So we click on clean data. It brings the GUI and allows us to import the data. So we go to import, can import it from workspace or from a file, and here we pick the TT table and say import it. It goes ahead and plots the data for us and shows a lot of useful statistics on the right side, and then allows us to do all these different types of things. So you see I have 32 values. Two of the values are missing, here and here. Those are those nans that I made. Min is -12, max is 10, min is 0.96, standard deviation is 2.9, mode, median, everything is shown. Okay, so this is amazing. And now let's say I want to get rid of these holes. I want to clean up the missing data, so I can click on this one here, clean missing data. And it brings me all sorts of different algorithms for filling the missing data. And you can either get rid of the missing data or you can fill for it. So here you see it says cleaning method fill, or you can say what? Get rid of it, remove. Right now I want to fill it. So I say fill, and then it says what algorithm? Do you want to do linear interpolation? Do you want to do next value, nearest value, spline? And there are lots and lots of different algorithms, and you don't need to write code for any of them. So let's say for me, linear interpolation or spline interpolation is good. Okay, and then there are other parameters that you can pick. And if you're satisfied with the result, then you go ahead and and you see you can check this, automatically preview changes. So now these red points are the newly added data for the missing holes, and this is the new curve. So you accept it, and now you see, now you have no missing data. You have 32 values, still the same thing. Of course, your median mode and stuff will change, but now at least there is no gap in your data. So now time to get rid of these two big outliers. So I go to clean outlier data. And here again, you can pick different algorithms for determining the outliers, and then there are parameters for that. So it says, again, do you want to get rid of them or do you want to remove them? I say let fill for them, and since a filling method, linear interpolation, let's say, or a spline interpolation or anything else. And then what kind of algorithm do you want to detect the outlier? Do you want a moving median? Do you want quartiles? Do you want percentiles? Whatever. Let's say I want the quartiles, right? And then it gives you a threshold factor, right? So what is it? 1.5 plus and minus 1.5 interquartile range plus and minus the 25th and 75th percentiles, which is the box method, and I have a video on that on my channel. Let's say I pick that and it shows me the outliers, so that's this one and this one, which is exactly what I want, and these are the fill data using Spline, and I accept it. So now it takes care of those two and replace them with those red dots. There we go. So now the original data, you see it in this blue curve, and the dark blue curve is exactly what you see for the new data. And if you don't want the original data, just uncheck it. Okay, so now this is your new data. No gap, no outlier, but clearly you see there is a ton of noise in this thing. So it's a good idea to smoothen it a little bit, right? So I go to smoothen data now and try to see if I can get rid of the noise a little bit. And now you have different algorithms again. There is moving median, there is moving mean, there is Gaussian filter, there are all sorts of algorithms. Feel free to try them, right? So remember, my original data is a sine, and this is the kind of data that I expect. So I can look at these different ones, right, and change the smoothing factor, right? For instance, you can do this different robust algorithms and so on, okay, and see what they do. Okay, it doesn't mean necessarily they always do better. Linear regression here and so on. So there are so many things, and the good thing is you immediately see their effects. Okay, so let's see, what does this Gaussian filter? Kind of. Let's see if I bump up the smoothing factor. Would that give me anything better? And when you click on it, you have to wait a little bit to see the result. It's a little bit slow, this tool, because it needs to do a ton of processing behind the scene. So be patient with it. Okay, and let me see if I change it to the moving median. Would that, yeah, that's not bad. And I can also do the moving mean as well with a higher smoothing factor. That's not bad. Now let's look at the mean as well. Yeah, let's say this is good and I accept it. So now I get rid of the input data. So now this is my clean data. It's a lot better, a lot less noise. And now what you want to do is, maybe for many of machine learning things, you need to normalize the data. If you look right now, your standard deviation is not 1, it's 0.24, and your average is not 0, 1.09. So you can normalize it. And normalizing means turning the average to 0 and standard deviation to 1. You see now your mean is almost 0 and your standard deviation is 1. Okay, so now it is going to normalize it for you, and it can do it based on z-score or any other algorithm. Z-score is good. Let's accept it. So now if you look, you see now your data is normalized with average at 0 and with standard deviation of 1. And if it's kind of too bumpy and jagged and you want to increase the number of samples, right now you only have 30 values, you can go to retime the timetable. And now you can upsample it or downsample it. Okay, so let's say I want to upsample this. And here you can change the step time or the sample rate. So I want to change the sample rate. Remember, initially the sample rate was 10 Hertz because my time step was 0.1, if you remember. So my original data is 10 Hertz. So now let's say I want to go to 20 Hertz. So I want to upsample it by a factor of 2. And I do that and I accept it. Okay, so now I should upsample it by a factor of 2. You see, I'm going to go from 30 data now to, let's let it get done, to 61 values. And again, it does it by linear interpolation here, which is okay to me. And let me turn this off so we can see what the upsample data. Here we go. You see I have 61 data. I got much closer to a more beautiful sign, and I could get rid of all of those things. And now you can go ahead and export your data to the workspace. So if I export it, it is going to export it as a new table, the timetable TT1. So if I go here, you see I can see TT1. Remember, TT was only 32 values with a lot of noise, with missing data, and with outliers. But now if I look at TT1, first of all, you see the sample rate is 0.05 now, so you have 63 data points, and it is much more beautiful. Okay, yes. So if you look at the original one, just compare, look at your original one, and look at what? Look at your cleaned with data after these 5 different operations. You get a kind of nice, beautiful sign as compared to this messed up data, which can come from sensor noise or anything else. And if you want, you can also what? Generate the script for it, or generate the function. So if you have to redo this over and over and over again on the same data, guess what? You can just generate the function. And now all you need is to just pass the new data with the timetable. And you see it has this method called fill missing with sp-line, fill outliers with sp-line, and quartiles, smoothen the data, moving mean, smoothing factor 0.5, normalize, and then retime with a sampling rate of 20, right? Or you can do the script for it. You see how powerful this tool is, and it's really amazing what it can do for you. And if you want, you can also save the data to a .mat file, right? And everything else for that matter. So hopefully this was useful to you and you learned. And if you have more columns in your timetable, it's going to show these other columns, and you can do the same operation on all these different columns, or you can uncheck them or check them and apply it to any of them that you want. Okay, so hopefully it was useful to you. I'll see you in the next video. Thank you.